Hello everyone, today I will tell you how to run a YOLOv11 on a small and very simple dataset of pipeline defect detection by only using PyCharm. First, you need to go in your PyCharm projects in C drive and create a new folder for the new project and rename it as YOLOv11. Inside of YOLOv11, you can create another folder where you can copy paste your dataset images. You can rename this folder whatever you want. Then you will copy paste all the images along with their txt files in that new folder you created inside of the YOLOv11 folder. The txt files contain the name of the defect for the pipelines. Each image have a txt file for it, and inside the txt file you can see the defect names for it. Now we will open our PyCharm and we'll go to add a new project. In the path we will click and open the project file that we have just created in our C drive in PyCharm folder. As you can see, our exact project has been opened now. First of all, we will go to the command terminal and will install a very important library and rename it. This library is named as Ultralytics. This library is very important to install because from this library we will import our YOLO file. For this library we have to simply write pip install Ultralytics. It will take some time to install it. Now we will come to our main code. As you can see, we have the code for the YOLOv11. We will run this code in our PyCharm. What this code will do is that it will first train the images and then test them to see the results and accuracy of the YOLO framework. Here you can see I am using CPU because my dataset is very small, so I am using the CPU for it. But if you have a big dataset, then you can use the GPU. For GPU encoding you can write 0 instead of CPU. Also, as you saw, for the epochs I only used 8 epochs as that is enough for my small dataset, but you can increase it for your dataset if you have a big dataset. You can see now that our model is training. You can see the epochs also. Here it have classified our images, like how many defects are detected in our model, and as the total images detected are only 78, so the split size is very small for us. As you can see, the train images are 54, validation images are 11, and testing images were only 13. The training will continue for 8 epochs. After 8 epochs, we will see the results like precision, recall, MAP, 50 values also. You can see the Ultralytics library that we installed at start of the video, and from that Ultralytics we have imported the YOLO for our coding. Now the training is completed and you can see the results for it. All this data is saved in that same path where we created our YOLOv11 project in C drive of PyCharm projects. First, you can see the graphs data results, confusion matrix. Secondly, now you can also see that YOLO have detected and classified the defect images. You can see the lines on the images and the names of the defects that YOLO have detected. This Excel file you can find all the data for the precision recall, loss data and MA253 values. But as our dataset was very small, that is why the results and accuracy is not as high as expected. But with a higher dataset, it will have the highest accuracy for the YOLOv11. Thank you all for watching this video.